For centuries, humanity has gazed at the stars, whispering questions into the void, wondering if we're alone. But what if the cosmos has been whispering back, and we've only just begun to hear it? A faint, rhythmic pulse, buried in the static of deep space, has been detected by a global network of radio telescopes. Scientists are calling it the signal, an anomaly so precise, so unnatural, that it's forcing us to rethink everything we know about the universe. This isn't just noise from a distant star or the echo of a dying galaxy. This is something deliberate, something engineered, something that could rewrite the story of existence itself. A team of astrophysicists, analyzing data from observatories across the globe, has published a paper that's sending shockwaves through the scientific community. Their claim? This signal, pulsing at intervals too regular to be natural, might be the first evidence of an intelligence beyond our world. In this video, we'll unravel the science behind this discovery, explore the chilling implications of what it could mean, and confront the possibility that we've just stumbled upon a message from the stars, one we may not be ready to hear. The signal was first detected in the early hours of a cold January night, when a radio telescope in the Atacama Desert picked up a faint, repeating pattern, buried in the cosmic microwave background. At first, astronomers dismissed it as interference, perhaps a glitch in the equipment or a stray signal from a satellite. But when the same pattern appeared in data from telescopes in Australia, South Africa, and the Arctic, skepticism turned to intrigue. The pulse repeats every 1.618 seconds, a number eerily close to the golden ratio, a mathematical constant woven into the fabric of nature, from seashells to galaxies. This wasn't random noise. Random noise doesn't align with mathematical precision across light years of space. The signal's frequency, centered at 1420 megahertz, matches the hydrogen line, a wavelength astronomers have long used to search for extraterrestrial intelligence. It's as if someone or something knew we'd be listening there. The paper, published in a peer-reviewed journal, calculates a 98.7% probability that this signal is artificial, based on its regularity, its narrow bandwidth, and its persistence across multiple observatories. This is no ordinary cosmic event. This is a beacon. But what makes this signal so unsettling isn't just its precision, it's where it's coming from. By triangulating the data, astronomers traced its origin to a point 4.2 light-years away, in the direction of Proxima Centauri, the closest star to our Sun. Proxima is a red dwarf, a faint ember in the cosmic night, home to at least one rocky planet in its habitable zone. Could this be a coincidence? The odds of a natural phenomenon producing such a signal from a star so close are vanishingly small, less than 1 in a billion, according to the researchers. The signal's source appears to be fixed, not drifting like a comet or asteroid, suggesting it's either stationary or orbiting something we can't yet see. The team's models show it's not coming from the surface of Proxima's planet, but from a point in space, possibly a satellite or a structure positioned to maximize its visibility to Earth. The implications are staggering. If this is a beacon, it was placed there deliberately, designed to be found by a civilization like ours, one just advanced enough to listen. Now let's talk about the rhythm of this signal. Its 1.618-second pulse isn't just mathematically intriguing, it's almost poetic. The golden ratio appears in the spiral arms of galaxies, the arrangement of leaves on a plant, even the proportions of the human body. It's a number that feels like a signature of the universe itself. For a signal to pulse at this interval, suggests an intelligence that understands not just mathematics, but the aesthetics of existence. The researchers hypothesize that this could be a deliberate choice, a way to signal not just presence, but intent. A random pulsar or quasar might emit regular pulses, but their periods drift over time, warped by gravity or stellar evolution. This signal is different. Its timing is locked, unwavering, as if calibrated by a clock that's been ticking for millennia. The paper speculates that such precision could only come from a technology far beyond our own, one capable of stabilizing a signal across cosmic distances, immune to the distortions of space-time. But here's where the story takes a darker turn. The signal isn't just a steady pulse, it's evolving. Over the past 6 months, astronomers have noticed subtle changes in its structure. The pulses are growing more complex, as if the signal is carrying information, a message encoded in its rhythm. Early attempts to decode it have yielded nothing conclusive, but the patterns suggest a binary or even ternary structure, like a language built from ones, zeros, and twos. The researchers compare it to the early days of computing, when simple binary code laid the foundation for our digital world. If this is a message, it's not a simple hello. It could be instructions, a warning, or even a blueprint for something we can't yet comprehend. The team's lead astrophysicist cautions that decoding it could take years, if it's even meant for us to understand. After all, a civilization advanced enough to send this signal might operate on a cognitive level as far beyond us as we are beyond ants. What if we're not the intended recipient? What if we're just eavesdropping on a conversation meant for someone or something else? The trajectory of the signal's source adds another layer of mystery. By analyzing its Doppler shift, the way its frequency stretches or compresses as it moves relative to Earth, scientists have determined that the source is not static. It's moving, but not in a straight line. The data suggests a complex orbit, possibly around an unseen object near Proxima Centauri. This could be a spacecraft, a satellite, or even a Dyson structure, a megastructure built to harness a star's energy. The idea of a Dyson sphere, proposed decades ago, was once dismissed as science fiction. But recent discoveries of dimming stars, like Tabby's star, have revived speculation about artificial constructs in space. If the signal's source is such a structure, it would imply a civilization capable of engineering on a scale that dwarfs our own. A single satellite, the size of a city, could generate the signal, but a Dyson structure would require resources and technology beyond anything we can imagine. The energy output alone would rival that of a star. The question isn't just who sent the signal, it's what kind of power they wield. Let's pause to consider the timing. Why now? Humanity has been scanning the skies for decades, ever since the first radio telescopes were built. The search for extraterrestrial intelligence, or SETI, has been listening for signals like this for over half a century. Yet this signal appeared only recently, just as our technology reached a tipping point. We're on the cusp of becoming a multiplanetary species, with probes exploring Mars, telescopes peering into the atmospheres of exoplanets, and quantum computers unlocking the secrets of the universe. Is it a coincidence that the signal arrived now, when we're finally capable of detecting it? Or was it timed to coincide with our technological adolescence? The researchers suggest a chilling possibility. The signal might be a response to our own broadcasts. For over a century, we've been leaking radio waves into space. Television, radar, even deliberate messages like the Arecibo signal sent in 1974. If someone out there was listening, they've had plenty of time to notice us. The signal could be their reply, a confirmation that we've been heard. But what if it's not a friendly reply? The history of contact between civilizations on Earth offers a sobering lesson. When advanced societies encountered less developed ones, the results were often catastrophic. Cultures erased, resources plundered, entire populations decimated. If the signal is from a civilization millions or even billions of years ahead of us, their intentions might not be benevolent. They could see us as a curiosity, a threat, or worse, an opportunity. The dark forest hypothesis, a grim view of the cosmos, suggests that advanced civilizations stay silent to avoid detection, like hunters in a forest. By broadcasting our existence, we may have broken that silence, drawing the attention of a predator. The signal could be a probe, a scout, or even a warning shot, a way to test our response before something more arrives. The researchers don't shy away from this possibility. One of them writes, "We must assume the signal is hostile until proven otherwise." The stakes couldn't be higher. Now let's explore the science behind the signal's transmission. Sending a signal across 4.2 light years is no small feat. The energy required to maintain a coherent beam over such a distance is astronomical. Our most powerful radio transmitters, like the Arecibo Observatory, can barely send a detectable signal to a nearby star. Yet this signal is clear, focused, and persistent, suggesting a power source far beyond our capabilities. The researchers propose several possibilities: a nuclear fusion reactor, a black hole's accretion disk, or even a zero-point energy device tapping into the quantum vacuum. Each of these is speculative, but they align with our understanding of physics pushed to its limits. A fusion reactor the size of a small moon could generate the necessary power, but a black hole or quantum energy source would imply a mastery of the universe's fundamental forces. If the signal is artificial, its creators aren't just advanced, they're practically gods. The signal's interaction with space-time adds another wrinkle. General relativity tells us that massive objects warp the fabric of space, bending light and altering time. If the signal's source is orbiting a black hole or a neutron star, its pulses should show signs of gravitational redshift, a stretching of the signal as it climbs out of a deep gravitational well. Yet the signal shows no such distortion. Its frequency is pristine, as if shielded from the effects of gravity. This could mean the source is in open space, far from any massive object, or it could hint at technology capable of counteracting relativistic effects. The researchers speculate about exotic propulsion systems, perhaps a warp drive or a wormhole, that could stabilize the signal's transmission. These ideas push the boundaries of known physics, but they're grounded in theories like the Alcubierre drive, which proposes faster-than-light travel by warping space-time itself. If the signal's creators can manipulate space-time, they're not just sending a message, they're reshaping reality. What happens if we decode the signal? The researchers are cautious, warning that even a friendly message could have unintended consequences. A simple data transmission could overwhelm our systems, like pouring an ocean into a teacup. If it contains instructions, say, for building a device or accessing a new form of energy, it could trigger a technological leap we're not prepared for. The discovery of fire transformed humanity, but it also brought destruction. A message from an advanced civilization could be a gift, a trap, or both. The Trojan horse looms large in the researchers' minds, a seemingly benign offering that conceals a threat. If the signal is a blueprint, it might be for a machine we can't control, one that could reshape our planet or even our reality. The team is already working with quantum computers to analyze the signal's patterns, but progress is slow. The complexity suggests a language that operates on principles we haven't yet discovered, perhaps rooted in quantum mechanics or higher dimensional mathematics. There's another possibility, one that's both thrilling and terrifying. The signal might not be from a physical source at all. Some theorists propose that it could originate from a simulation, a sign that our reality itself is a construct. Simulation theory, championed by philosophers and physicists alike, suggests we might be living in traumatic scenes unfold as the signal's implications sink in. Governments are quietly mobilizing with whispers of a global task force to monitor the signal and prepare for what comes next. Space agencies are redirecting telescopes, recalibrating instruments, and launching new missions to Proxima Centauri. The public remains largely unaware, but the scientific community is on edge, torn between excitement and dread. If the signal is a message, who is it for? Are we the intended recipients, or are we merely bystanders in a cosmic conversation? The researcher's paper ends with a haunting question. If we answer, will we regret it? For now, the signal pulses on, a steady heartbeat from the void, reminding us that we may not be alone and that knowledge comes with a price. The moment of truth will come soon. In late 2026, the signal's source will align with Proxima Centauri's habitable zone, offering a brief window to observe any changes in its behavior. If it remains a steady pulse, it might be dismissed as a natural phenomenon, though an extraordinary one. But if it shifts, modulates, or intensifies, we'll be forced to confront the reality of an intelligence reaching out across the stars. The researchers are clear. We need to be ready. Plans are already in motion to send a response, a carefully crafted signal of our own, though debates rage over whether we should stay silent. The dark forest looms large, and every choice carries existential weight. So what do you think? Is this just a cosmic coincidence? Or is it the first whisper of contact with a civilization beyond our own? The signal is out there, pulsing, waiting, and it's up to us to decide what happens next.